Good day, students. Today we are going to look at another session for formula of ionic compounds. In the previous session, I gave you methods of determining formula of ionic compounds with simple binary elements or binary compounds, which may be compounds like sodium oxide, sodium chloride, aluminium bromide, like that. Today, I want to just tackle compounds that could be having polyatomic ions. Okay, right. By polyatomic ions, I'm referring to ions which are made up of more than one atom. That's why we're calling them polyatomic ions. Okay, some of these polyatomic ions are positively charged, some of them are negatively charged. Okay, you can look at a polyatomic ion which is positively charged as NH4 plus. Okay, this one is called ammonium. Okay, that's a polyatomic ion. So this one is an ammonium ion. Okay, and I can also look at another one which is negatively charged, such as sulfate. Okay, so this is a sulfate ion. Okay, remember that the sulfate, okay, it can also be spelled, especially for our American textbooks, you actually find out that it can be spelled like that, either PH or F. Okay, both are acceptable. Okay, so let's just look at an example of an ionic substance that contains either a positive polyatomic ion or a negative polyatomic ion. Let's start with one which we can say aluminium sulfate. Aluminium sulfate. Okay, aluminium sulfate. Okay, like what we covered before, aluminium can be found on the periodic table. It's in group 3, and you can tell the charge of aluminium will be +3. So I write my symbol Al. I go to the periodic table. The charge for aluminium is going to be +3. Okay, so I will write Al +3 because we said the charge for the metal is equal to the group number. So we write Al +3. Okay, unfortunately, some examiners might give you the formula, some examiners will not. So these ones you will have to memorize. Okay, so we have sulfate. Don't confuse the numbers. These are the number of atoms in the sulfate ion, and the charge is at the top. Okay, so we have our charges there. As before, what do? We want to swap the numbers only, not the sign. Okay, so the 2 comes down to aluminium, the 3 goes to sulfate. Okay, what would be our final answer? Our final answer, we're going to write it is Al. Okay, now the 2 is with aluminium. Okay, this is the most important part, SO4. Okay, but there is now a 3, and this 3 must affect everything about the sulfate. So remember to put the bracket. Okay, so that the formula for aluminium sulfate is going to be Al2 open bracket SO4 close bracket 3. Okay, this is how we write the formulae of ionic compounds that contain polyatomic ions. Okay, now we can be given another one. Let us just say ion 2 carbonate. Ion 2 carbonate. Okay, the story here is rather different. Okay, ion is found in transition block. Okay, so these elements can have more than one charge. So whatever is put in brackets, this is to help you the exact charge. Okay, if there is 1 here, it means the charge on ion is +1. If there is 2 here, it means the charge on ion is 2. Okay, so if there is Roman numeral is 2, they are simply informing you that you have Fe, because you cannot use that rule which we're using. Okay, you use the number in Roman numeral. If there's a 2 here, it means the charge on ion is +2. Okay, if there is 3, the charge on ion will be +3. Okay, so transition elements have more than one oxidation state, and when we write their names, we normally put Roman numerals in brackets to indicate the exact charge that we are talking about, so that our ionic compound is not going to give us an ambiguous answer like that. Okay, so iron 2 carbonate. So we write Fe plus 2. Okay, carbonate, right? Like I said, you have to remember the formula for iron carbonate is CO3 and a 2 minus. Okay, again, that's a special case. If these numbers are similar, okay, the charges cancel out. No need to swap. Okay, whenever I have determined the charges at the top there and they happen to be similar, it means no swapping at all. The formula will not change. So the formula for iron 2 carbonate is going to be FeCO3. Okay, this is one of the special cases that we might have, and we might have a transition element involved, and we might have similar charges at the top. If there's a transition element involved, remember the Roman numeral is used to tell you the charge. Okay, as a summary, if there is 1, it means the charge is plus 1. If there is 2, it means the charge is plus 2. Okay, if there is a 4, it means we are talking of plus 4 charge. If there is a 5, it means we are talking of plus 5 charge. Okay, so whenever you see some salts that you use for your experiments in the lab, especially for identifying ions, sometimes you see manganese 4 oxide. Okay, they are simply telling you that the charge on manganese there is plus 4. Okay, that was our session today, formula of ionic compounds, but now we're dealing with polyatomic ions. Remember, some examiners might give you the formula of the polyatomic ions, some will not give you the formula of the ionic polyatomic ions. So the onus is on you to draw a table and you learn how to write the formula of the polyatomic ion. 2 things to watch out here. The polyatomic ion is going to have more than 1 atom, so there will be a number at the bottom indicating the number of atoms present, and there's a number at the top to tell you whether the polyatomic ion is of a positive in nature or is negative in nature. Please, like I said in my previous video, if you like the video series that I am giving you, just remember to subscribe, share with your friends so that we can use them, especially when we are preparing for our exams. Usually I use methods that are direct and they can be of benefit to you, especially when you're preparing for your exams. Bye-bye for now.